fine. He said, that's fine. You don't have to look into flat Earth. But until you do, he said, until you do look into flat Earth, you will remain a slave of the Matrix. And interestingly enough, at this point, this was more or less November, December 2015. I had already mentally resigned from the U.S. military for 3 years. I'd already resigned because of Benghazi. I realized, and I saw for myself, I'd been working with U.S. as an Army officer, working for State Department for a good 10 years. And so what I did, I turned my physics awareness, I turned my studies into analysis of the shape of the Earth. Radar is simply another form of radio transmission. Radio includes anything within the range of the electromagnetic spectrum. Electromagnetic spectrum, also known as light. Radio is a transmission of light, whether it's visible light or radio waves, which are not visible. When it comes to radio transmissions, there must be a transmitter and a receiver. There can be a reflector or a transmittal unit along the way. However, in the end, there's got to be at least a transmitter and a receiver. And in the case of radar, radar transmits a signal and it bounces off a reflector and then it comes back to the receiving station. Or it can go to other stations if they're set up in the network properly. Long story short, radar emits a signal, it bounces off something, and then it returns to a receiving unit, and the receiving unit maps that reflection accordingly. If there is no reflector, then there's no return signal, and then the object does not show up on the radar, for example, off the screen. Notice, there's no curving around anything. It goes out in a straight line. Radio signals always travel in a straight line. So the transmitter sends the signal out to the target, bounces off, and it comes back in a straight line. Radar cannot travel over the curve, and hence, radar is dependent on line of sight, direct beam from the transmission to the target. It reflects and it comes straight back. There is no curving around anything, thus is radar. The fact proven from multiple points that there is no Coriolis to the motion of the Earth. And I'm speaking from a pilot's perspective, also an engineer's perspective, because I obtained a degree as an engineer before I went to flight school. So I'm both a pilot and engineer at once. So number one, there is no rotation of the Earth, proven by the fact that a helicopter pilot can hover the aircraft indefinitely, motionless, above a single point of the Earth. If the Earth were spinning, as soon as that aircraft left the ground, the Earth would spin out from under it. Now somebody may say that the air of the atmosphere rotates along with the Earth, which is one of the most absurd concepts imaginable, because if that were the case, then all wind would travel with the Earth. There would be no alternating wind currents. And we know that the jet streams fly overhead, clouds move in multiple directions overhead, and a kite flying over the stationary Earth. The fact that a kite flies because of wind passing, that proves that the air does not move in unison with the Earth. Number two, airstrips do not rotate away from a landing aircraft. Anybody who's seen a pilot's view when an aircraft lands, well, the aircraft lands to a motionless airstrip. If the Earth were rotating, the pilot would have to turn to the angle at which the airstrip is rotating away and land at the speed of the airstrip, which is absurd, simply absurd. Airstrips do not rotate away from the aircraft, and on an east to west landing strip, if the aircraft is landing to the west, the airstrips do not land moving towards the airplane. That's insanity. Okay, simply stated. I've done many of them personally. I've flown more than 1,070 hours in both helicopters and airplanes, and I will tell you factually that aircraft meet their checkpoints, they take off, they meet their checkpoints, and they land exactly as planned on a flat stationary map. No pilot, I say again, no pilot has ever accommodated for the rotation of the Earth when planning flights and take off to checkpoints along the way, and then landing. Pilots can plan so well that they can take off and land hundreds of miles away down to within 30 seconds of their planning because the Earth simply does not rotate.
Yes, absolutely. Number one, there is a rate of descent, and we can all imagine these are simple concepts, and I'd like to reiterate that in all of my technical discussion, in any of our technical discussion, it needs to go further than, we need no more complexity than 10th grade science, 10th grade math, Pythagorean theorem, 10th grade physics, 10th grade chemistry, basic chemistry. This is chemistry 101, college level, 10th grade chemistry at the high school level. One can imagine if an aircraft is flying at elevation 35,000 feet, well, it has to descend to land on the ground. Well, it's still flying in the air. It's not going to point its nose straight down and go straight to the ground. No, it's got to gradually descend from altitude down to zero. Well, we call that rate of descent. A lot of people don't talk about this. Now, I'm bringing up a new topic to Flat Earth, and I'm really bringing up a new topic to the average pilot. The average pilot does not talk about rate of descent. And how do I know? Because I've talked with several pilots, and they cannot quote their rate of descent. Why do I know it? Because I memorized Army Federal Regulated Rate of Descent, which was 500 feet per minute. For 18 years, I memorized 500 feet per minute. That's for my first 2 years as an Army aviator, I memorized 500 feet per minute is the standard rate of descent. Well, that's for landing. Okay, let me reiterate. That's for landing to a full stop. When the airplane wants to land to the ground and stop, that's 500 feet per minute. But we, in the flat Earth community, we know that for an airplane to fly around the globe, the supposed globe that is, there's a rate of descent associated with 8 inches per mile squared. So if we do the math, the 8 inches per mile squared at the average, assuming an average airspeed of 500 miles per hour, or that's really a ground speed, but it's moving through the air at 500 miles an hour. Associate that with 8 inches per mile squared. Well, the math gives us the following: 2,777 feet per minute rate of descent for that airplane to follow the globe. Okay, and that is a continuous descent, not to land. That is a continuous descent while the aircraft is at altitude flying along. Wow. Well, let's compare that. Let's make the comparison now. 500 feet per minute to land the airplane to a full stop at an airport. On the globe, the airplane has to descend continuously at 2,777. That's more than 5 times the rate of descent for landing, and that's a continuous descent. So I did some more math today, by the way, Vika. Thank you for asking. It's average 500 feet per minute. Okay, so I looked up gravity, 32 feet per second squared. Okay, that's the quote supposed gravity, right? If you drop something in a vacuum, okay, it falls at 32 feet per second squared. Well, let's convert that to feet per minute. That is 1,920 feet per minute. Okay, that's gravity. Now, let's remember, an airplane flying around the curve of the globe at 500 miles an hour must maintain a rate of descent of 2,777 feet per minute, which is almost 1,000 more feet per minute than something falling in free fall. That's absurd. That's the most absurd measurement we can have. So I'm bringing that to the flat Earth community. That's what the math gives us, Vika, and everybody else. Can we see the perspective here? The 8 inches per mile squared around the curve of the globe at 500 miles an hour, that's faster than free fall. That's more absurd than one can imagine. Vika, that is the simple math. That's high school math right there.
So, I'm intrigued, and I keep taking notes as you keep talking. That there's always this new. It's not new measurements. It's not new rate of descent. It's nothing new. But but what people seem to forget is the globe model, the heliocentric model. That science and math is never used in a functioning application.
Exactly.
Never, ever.
Because it's fraud if they ever do.
Exactly. So kudos to you, and rate of descension just made my list of bullets in the gun.
That's a foundational effect of flat Earth, isn't it?
Amen, brother. Amen. That and elevation angles, that and triangulation, and the list just keeps growing and growing and growing. And so, Thank you. I don't want to take a lot of time here, but thank you, Rob.
Yep, and that's my point, Lon. That is exactly my point, and that's why I send out these messages to everybody in the group, so everybody can see and understand. Anybody can do this math. Pilots don't know anything that's not normal. They have more experience with it, but just because they're a pilot doesn't mean they know something special. Anybody can do this math, and anybody that does this math and can explain it, well, they're smarter in this effect than the average pilot.
Amen.
They can run.
Amen. So I sat in that co-pilot seat for so many times, and had I known then what I know now, it just would have been a no-brainer. I know you bring a plane up to elevation, to your altitude, it's locked in, and you don't bring it down until your point of destination is arrived at. It's point A to point B. That's it, and there is no curvature. So, all right.
I don't know what to add after you guys. I'm so happy to be here. You guys are amazing. I noticed that at 500 miles an hour, you move about 40 miles in 5 minutes, and I don't ever see any chemtrails with any sort of curve much to them.
Well,
they're always straight lines.
Yep.
So if you can follow a plane for 5 minutes, that's a good amount of time. 40 miles is going to show something.
Gene, that's a prescient observation. Prescient, not precious, but prescient, but precious as well. Guess what? My mother pointed that out to me this week. My own mother pointed that out, so that's awesome.
I have a couple. The first comment by F.E. Patriots: at a speed of 500 miles per hour, the plane would fly at just over 8 miles per minute. Therefore, the rate of descent in the first minute from the starting position is just under 50 feet and then increases
exponentially.
Yeah.
31 miles at the end of the 500 miles of its flights from the starting position. So that averages about 2,800 feet of descent per minute.
Wow.
There you go. That's exactly my calculation. 2,777 around the globe. Exactly.
F.E. Patriot's pretty good. He's really
that's
good.
all ficticious. Fictitious.
Yep.
It's a dreamland. The globe is from fairyland. Dreamland.
Non sequitur.
Non sequitur.
Yes. And the fact that at no educational level, at zero educational level, is anyone ever taught the Earth curvature equation. You don't get it in preschool, you don't get it in elementary school, you don't get it in middle school, you don't get it in junior high school, university, undergraduate work, postgraduate work, doctoral work. You don't get it.
Talk about it.
Because it doesn't exist. The curvature equation was created by people who were looking for the curve.
Yes, exactly.
But what equation they gave us that makes zero sense is E equals mc squared, and you can't apply it. You can't apply that to anything in real life.
That's to support their myth of the nuclear bombs. That's all that was.
Yeah, and gravity.
Focus,
That's their magic fairy dust.
Reference fairyland. We all know this quote. I looked up the quote by Tesla on Einstein.
Yeah.
And I'll just reiterate it here. So because it was on the subject a couple minutes ago, Einstein's relativity work is a magnificent mathematical garb. This is heliocentrism as well. Magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple, whom ignorant people take for a king. Its exponents are brilliant men, but they are metaphysicists rather than scientists. Wow.
Well, there it is.